Okay, so come back to the analog system. Okay, if I were to go back to the AX plus BU stuff, alright, you remember that the transfer function can be represented by this thing, alright, where your C comes from your this C, your B comes from this B, and then etc. Alright, so likewise for your transfer function in the discrete domain, or your Z transfer function, this is S transfer function, your Z transfer function now can be represented by your H over here, your P, you see your J, no, not J, I mean your phi, you know, type of stuff. So a transfer function can be re-represented in terms of this form, alright? And we have already found for you that this thing over here, alright, with a certain transfer function of 1 over s squared is this thing, correct? So therefore what we have, alright, is to just use this formula to help us get our Z transfer function already. Okay, so let's start. Okay, so please take note, this is not P. Alright, this is the capital gamma. Okay, so this thing over here, remember, is your phi. This is over here is the gamma. This over here is your H. Alright, so I'll just simply subbing in all the stuff. So my H is 1, 0. Okay, with a inverse. Actually, this is inverse. I actually didn't write it. But anyway, so Zi, so it's identity matrix minus your phi. Your phi is, maybe I should write as 2 times 2. Alright, so I have Z and Z over here. Okay, maybe hold on a while. Okay, then minus the phi, which is your this thing over here. Right, and then this whole thing inverse. Alright, multiply by your gamma. Okay, so my gamma is t squared over 2 t. Okay, so this thing over here is your this thing. If I were to write it down, H, alright, this is your Zi, this is your phi, this is your gamma, capital gamma. Alright, it's the same thing. So I'm just trying to rewrite things already, you see. It's pretty neat now. Alright, so next what we're gonna do is to evaluate these certain so-called the matrices in order to find your transfer function. Alright, so give me a little space. Hold on a while. Okay, so you have all this that I've written to you. Alright, our purpose is to find GZ. Okay, so next is that I'll just first evaluate this thing first. Alright, so what I would have is Z minus 1 is, what do you have? You have Z minus 1. Alright, 0 times T, it's, sorry, 0 minus T is minus T. 0 minus 0 is just 0. Z minus 1 is over here. Okay, so I would have inverse. So this thing over here I have rewritten as this thing over here. Alright, while the rest for the H I'll just simply rewrite as this thing. Sorry, I should have copied. So hold on a while. Okay, so I have this thing over here because I don't want to cheat your feeling, so I'll paste in front of you. Okay, so likewise the transfer function g of z is equal to this. Alright, next step I will do the inverse. This is a matrix inverse. Alright, so therefore over here I can do the inverse by having this general equation. If it happen that you forgot the inverse, this is how we write this. A, B, C, D is equals to 1 over the determinant. This is determinant of this thing. AD minus BC. So AD minus BC. Okay, and then the AD, you switch the position to D and A. Alright, I just flip. B and C I change to minus B and minus C. Okay, so in this case, for example, for this case, I will have 1 over Z minus 1 times Z minus 1, I will have Z minus 1 square. Alright, minus away Z times minus 0 times minus T is actually 0. Okay, so this portion over here is similarly like this thing. Or this thing over here is just this one. Okay, so therefore, let's continue. So my D, alright, this thing I read as Z minus 1, I'll just rewrite as Z minus 1. This at first is A, I'll just write as Z minus 1. It's the same thing, but I just want to show you where the definitions, because it may have this thing over here be Z plus 1. I don't know. Alright, so be careful of that. That's why I want to show you this general equation. Alright, so that you will not have any careless mistake. Alright, so this minus T, it becomes T because I flip the negative side. Right, so this 0 is simply just 0 lah. Okay, and then yeah lor, so this thing over here is your inverse. Okay, So let me just simply rearrange a little stuff for a while. Okay, so therefore I have this thing representation of this thing inverse. Alright, while the rest are the same, you see. You can check your own, I didn't check your feeling. Okay, next I'll just multiply this in so that at least this is a constant, this is a matrix. If I put them together, it will be nice. Alright, so what I have is, so z minus 1 times z minus 1 square, I will have z minus 1. Yeah. Alright, this is z minus 1 times z minus 1 square, I will have 1 over z minus 1. Yeah. Then this t times z minus 1 square, I would have this thing. Alright, so this thing times 0 times this one, I have 0. Or z minus 1 times this 1 over z minus 1 square, I would have 1 over z minus 1 also. Okay, so I just simply multiply the constant inside all of them. That's what I'm doing. If you don't know what the hell I'm doing, I'm just doing simply that. So I'll change this thing or rearrange this thing in terms of this thing now. Okay, so this is all purely matrix now, right? There's no inverse or whatever. It's pretty nice. So now I can evaluate row times column. Alright, so row times column, 1 times this one is, I would have 1 over z minus 1. Alright, 1 times this one is just itself. And then 0 times 0 is even 0. Alright, so therefore this is the first one. Alright, this thing times this thing now. Alright, row times column again. So I would have t over z minus 1 square. Alright, 1 times this one plus 0 times this one. It's just, yeah, you get what I mean? So therefore next is this thing over here. Is it? Hold on a while. Sorry. This thing, it should be like this already. That's all. Okay? Next, I'm gonna multiply with this t squared over 2, right? Because this is the matrix from there. So this part over here becomes this one. Alright, while this thing over here becomes this one. I mean, it's still there. This thing over here is still this one. Okay, so let's evaluate this matrix. While not forgetting that we are still finding g of z, the transfer function. Okay, so next step, row times column again. Oh, there's only one row and one column. So therefore, yeah. So 1 times this one, I would have t squared over 2 times 1 over z minus 1. Alright, this thing over here times this one. Alright, plus this thing times this thing. So what I will have is t squared over z minus 1 squared. Okay, is equals to your transfer function g of z. Alright, so now we have something like a nice only now. So I'll simply rewrite this as t squared over 2z minus 1. Alright, because this thing over here I rewrite as this lah. Okay, plus t squared. Alright, z minus 1 squared. Okay, and next this I want to, because if you remember the denominator are not the same, so I want to let them to be the same denominator. So I'll just copy this, I'll paste it over here, I'll bring this out a little bit. Okay, and I'll just multiply by a z minus 1. Where am I? So this thing over here becomes square. Alright, you get what I mean? So I'll just simply wanting their denominator to be the same. So I'll just simply multiply by z minus 1. So z minus 1 and z minus 1. So the denominator will become z minus 1 squared out, right? So this is what I'm writing down over here. In case you don't know. If you don't understand still, you just watch a few seconds back. Alright, just repeat and repeat until you know what I mean, or you just write it down on paper. You'll get a feel of it. Alright, so next thing I'll just merge them all together. So I would have, so I evaluate t squared times z is t squared z, t squared times minus 1 is minus t squared, alright, plus t squared, okay, all over 2, this is z minus 1 squared, okay. Hey, and do you see any careless mistake? Alright, it's because, alright, we shouldn't have over here, this t squared over 2 should be multiplied on top. We cannot multiply straight away like this. Okay, this is the part that I realized. Alright, so this t squared over 2 over here, this thing over here should not be written as this. You can rewrite this thing as this one, But in our case right now, it is recommended that you rewrite this thing, or in other words, I will just erase everything first. Okay, because over here, this minus t square and this thing will cancel out each other. So over here, you have t square z over 2z minus 1 square. Then this answer is not the same as the answer that we want in the previous old times where we just derive this thing. If you remember at the second video of our playlist in this l10v2, okay, we actually z transform. This answer is t square over z. This should be the answer. Alright, so however, from here you can clearly see that this is not the answer at all because of this particular step. Alright, when we sub in the z minus 1, because I don't want to confuse you anything, and this is why I just want to rewrite everything. Alright, rewrite everything in a way that can help us to derive certain answers. So instead of writing multiplying all together, I'll just multiply as t squared over 2 divided by z minus 1. I can also do that because it's just some constants. I can move it over here. Nonetheless, you can also rewrite as t squared over then this like that. You can also rewrite that as that, but it's not recommended in this scenario. So I'll just rewrite as this plus t squared z minus 1 square. Okay, and next I'll rewrite, because the fractions, this thing over here is square, this thing over here is just to the power of 1. So I'll just multiply. So I have t squared over 2 times z minus 1 and then z minus 1 square. Okay, so in other words, I'll just simply multiply z minus 1 over here lah. This is equals to 1. Alright, well, I didn't change any information over here, you see. Just take a look to compare. Okay, so therefore this thing over here is still the same. So instead of writing as this thing, I can rewrite also over here as square. Right, because z minus 1 times z minus 1 is still z minus 1 square. You see this whole thing. And then plus t squared over z minus 1 square. Alright, so what do I have? So what I have is t squared over 2 times, I'll just multiply this thing all over to the other side. I have this thing, t squared over 2 plus t squared. Alright, and the denominator is z minus 1 square. Okay, so what I can do now is that t squared over 2z, or t squared minus t squared over 2 plus t squared, what do you have? You'll have plus t squared over 2, correct? For example, half minus half plus 1, you'll have what? You'll have half ma, so it's the same thing that is in reference to this calculation. In case that you don't feel it, you just write it down for you to see. Alright, so I have z minus 1 squared. So I'm just simply doing the expansion, things like that only. Okay, next we are at the last step already. Alright, this thing over here, this is t squared over 2, the constant. I factorize them out. I have t squared over 2. Alright, z plus 1. Alright, this is the numerator. Alright, so I factorize t squared over 2. I'll have z plus 1 ma, Alright, so and then divided by z minus 1 square. And this is the answer. That is the same that we have done in the previous section in video 2. Alright, and therefore this has also proved to you that the state space, while using the state space, alright, you can also derive the same digital transfer function as when you z transform it. Alright, so we have the same answer exactly. So this proves that our state space is a good method to also to represent our transfer function. And lastly is that why do you want to represent in terms of state space? Because you want to read at a certain state of the responses. Alright, because if you still remember, this is our state space, correct? Your state, this particular x1 k plus 1, is in terms of all this state. So you can straight away know at this particular k plus 1, for example, you have a certain signal, alright, digital signal, discrete signal also to speak. This is for example this is k, for example k plus 2, k plus 1, and k minus 1, k minus 2. So if you were to write in terms of a state of a certain state variable, you will know that at this particular k plus 2, what is the value. So at k plus 1, you will know what is the value. If you have happened that you know k other stuff, if you represent in terms of other type of state space, you eventually get all other informations from other states. So this is one state, this is one state, this is one state. So you can clearly see how the response of each of the state it is. Alright, and you can straight away know what the hell is going on within this particular state, and what are the informations that is bounded within this particular state. All the informations are within the state space. So this is the purpose of being convenient with the state space, although this is this is a hell lot of work to do. Alright, and therefore we have proved to you that this this thing over here, alright, is legit. Okay, certainly we have two methods to derive your digital transfer function. Next, in the next video, we'll talk about how to use the transfer function to derive back into your state space. Previously, we used the transfer function of the S domain to go into the state space, then to the state space, we go into the Z domain. Alright, so now we're going to reverse, we use the GZ, we're going to go back to the state space, and eventually to go back to the transfer function over here. Okay, so in the next video is not very good, but I recommend you just watch if you need to watch. Alright, so yeah, so see you there to go into the derivations of having the GZ into the state space. Alright, eventually I think I'll just go to the state space will do lah. Okay, and I'll not go into getting back this thing. I'll repeat again, and I take back my words that I cannot re-represent my state space back into the transfer function. Okay, to a certain extent, because later on you will know how it goes. Alright, but we however can represent the transfer function of the Z domain in terms of a state space. Okay, so we're gonna go back to the backtrack. So in other words, just now what we have done is that we've taken this formula and we derive, alright, all the way to where am I? We derive all the way to this answer, alright, using the state space. So now the next question is, can we use this transfer function in the Z domain to derive back your state space, which is where we are just now, your state space. Okay, or eventually getting back your state space all over at this side. Where am I? This one. So the question is, can we rewrite that particular Z domain transfer function, okay, back into here? And the answer is yes. So the purpose of the next video is to prove to you that having this thing, you can go back to here, but in a way that at the last part I stuck. Alright, so therefore see you there.